Hello everyone and welcome to this series of lessons on object-oriented programming in Python. I am Mohammad Hassan Naim, working as Assistant Professor at University of Engineering and Technology, Lahore, Pakistan. I am recording this series primarily for the students of my class to whom I was teaching the course of Computer Programming 2, and then came the COVID-19 pandemic. The most important module of the course Computer Programming 2 is Object-Oriented Programming, which we just started before the closure of our university. So I decided to record the lessons on object-oriented programming from very beginning so that anyone interested to learn could use this. This will be a complete course on object-oriented programming. You will be given different tasks and I'll try my best to answer your queries as well. You'll get the link to programming files we'll be using in the lessons. So let's first discuss about the target audience and expected prerequisite skills before you start the course. The students of my class took their first course on computer programming with me in last semester, and that was the first programming exposure for most of them. They didn't study object-oriented programming in that course, so most of them have absolutely zero experience of object-oriented programming. So we'll start from very basics and we'll try to cover most of the concepts needed for object-oriented programming. Moreover, we'll consider a bit practical scenarios rather than just the example classes like class A, class B or class C. Don't worry if you don't know what a class is, that's what we'll be covering in this lesson. The prerequisites needed to start this course include basic programming skills in Python like basic data types, which includes numeric data type, strings, lists, tuples, set and dictionary. Decision making, which includes if-else and nested if-else statements, user-defined functions and using the built-in modules. It is also preferred that you know about lambda expressions, list comprehension, built-in functions, filter and map, and generators. If you don't know about these preferred list of topics, you can still start this course and learn these as needed. But the first list of basic programming skills is mandatory to start this course. These are the topics we'll be covering in this course. And this is almost everything needed to be good at object-oriented programming. Now let's discuss what actually is object-oriented programming. The type of programming which you had been practicing before is known as procedural style of programming. In procedural programming, concept of procedural call is used. Procedures, which are also known as routines, subroutines or functions, simply contain a series of computational steps to be carried out. And it is a top-to-down approach. So procedural programming is about writing a list of instructions to tell computer what to do step by step. On the other hand, in object-oriented programming, we treat everything like a real-life object, which has some properties and functionalities. So object-oriented programming is about encapsulating data and functionality into the objects. In object-oriented programming, we create objects that have attributes similar to real-life objects. Consider a real-life object, for example, a fan. It has some properties like the color of the fan or the number of the blades it has, etc. And it can perform some functionalities like a fan can turn on or off, it can speed up or speed down, etc. Likewise, in object-oriented programming, the objects we create have properties and functions. Now let's see how an object is created. Objects are created from a class. Basically, in object-oriented programming, we program a class and that class contains complete attribute details for its objects, and then we can create as many objects from the class as we want. Python is object-oriented programming language, and whatever we create in Python, for example a simple integer variable, that is basically an object of some class. Int variable is an object of int class. Likewise, list is a class and we can always create as many list objects as we want. So knowingly or not knowingly, you have been using the classes and objects. Now let's see this in actual program. Here we have a simple variable x equal to 2. There is a built-in function type in Python which we can apply on any variable to find its data type. So if we apply type function on x and print the result, you will see it is printed as class int, which means that x is an object of class named as int. If we change it to 2.1 and rerun the code, you will see that now it is printed as object of class float. Similarly, you can verify it for string data type, or I'll do it for a list data type. And this time it is printed as class list. Not just that, even if we have a function named as test function with two input arguments a and b and simply returning a plus b, which is not really useful, but just to show you that if we print type of this function, you'll see that it is printed as object of class function. So everything we create in Python is an object of some class. So anyone who ever wrote a program in Python has used objects. But when we talk about object-oriented programming, it's about creating our own class with our own given name and setting different attributes for objects of our class. You can also think of class as a factory where we set all properties and functionalities for the products being manufactured, and objects are these products of the factory. A class is also considered as template or a blueprint for the objects. So think of this factory which is manufacturing boxes. These can be many boxes and these are the products of this factory. In programming terms, this factory is a class named as box, and the boxes are objects of this class like box 1, box 2, box 3 and box 4. Let's discuss about terminologies of the class and object. A class is also called as type, but you will find this term being used rarely, and hence we will be using the term class throughout this course instead of type. The object created from a class is also known as the instance of the class. We will be using both terms object and instance in this course. In fact, there is another built-in function in Python as isInstance. We can use isInstance to verify if a particular variable is object or instance of a particular class or not. We use it as isInstance and pass in the variable name first and then the class name as second input argument. It will return true if the passed variable is object or instance of the specified class. Now we know about class and object. Let's see in detail what is inside an object. For example, this real object box has some properties which define the state of the object. For example, color, length, width and height are properties of this object. Then it can have functionalities which define the behavior of this object. For example, a box can be opened, it can be closed, it can be locked or it can be unlocked. Just like real life object, a class object contains two types of information termed as attributes of the object. First is the data attributes which define the state of the object. These are also known as properties of the object. Mostly we'll be using the term data attributes rather than property in this course. Second is function attributes which define the behavior of the object. These are also called as methods. We'll be using both terms functions and method for these attributes. Dot notation is used to access the attributes of the object, both data and function attributes. I'm sure you have used this dot notation earlier, like for a list named as A, we can use a.append3 to append 3 in that list. The difference of dot notation for data attribute and function attribute is that in case of data attributes we use object and then a dot followed by the name of the attribute. While in case of function or method attribute, we have to put parentheses after the method name. Inside parentheses we have to pass in the input arguments if any. Let's see this difference in a code. I'll change this x to a complex number by adding the imaginary part as 5j. And now if we run the code, you will see that x is an object of complex class. We know a complex number has real and imaginary parts. We can access those real and imaginary parts of x using x.real and x.imag. If we run the code, you will see that real and imaginary parts of x are printed. We can also find the conjugate of a complex number by using conjugate method available in complex class. So let's find the conjugate of x as x.conjugate. This method doesn't need any input argument. If we run the code, you will see correct conjugate is printed. The point I want you to show here is that if you see carefully, the way we use real and imaginary on line 3 and 4, we didn't use parentheses after .real and .image. While in case of conjugate on line number 5, we use parentheses after that. This shows that real and imaginary are data attributes or properties of the x, while conjugate is a function or method attribute. Keeping in mind the detail of data and function attributes, We can consider the box example again and let's see these attributes in a coding style. It will have data attributes like length, width, height and color. Then it will have these method attributes open, close, lock and unlock. So an object box1 of the class box will be created as box1 equal to box followed by the parentheses, where box1 is just a variable name and box with capital B on the right side is the name of the class. Then we can set data attributes of the box1 as box1.color equal to blue and so on for other attributes. There is a better way of doing this which we will explore when we will start creating our classes from next lesson. We can apply methods on box object as box1.open or box1.close, etc. Another thing about object properties or data attribute is that we can have constraints against different attributes. For example, the color of the box can be from these 4 colors only and not any other. Or length can be between 15 cm and 30 cm, width can be between 10 cm and 22 cm, height can be between 8 and 15 cm. We'll see how to do this in coding later in this course. Let's review different terminologies we have discussed. On top you can see we have a class and then from a class we can create object or instance. The object or instance of a class has attributes and those are 2 types of attributes. One is data attributes, also known as properties. The other is method or function attributes. Then we can also have class level attributes and again those are of 2 types, data attributes and method attributes. We'll see detail of class level attributes later in the course. We saw box example to understand the idea of object and class. Now let's discuss a couple of more examples of objects for better understanding of concept of object, class and its attributes. Let's consider bank account as a class and account1 is its one object. This class can have following attributes for its objects. Title. It will be the title of the account and it will be the data attribute. We'll access this for account1 object as account1.title. Account type. Account can be a current account or a saving account or may be of some other type. This will also be a data attribute and we'll access this for object account1 as account1.account type. Find balance. This will be a method attribute to find the balance of the account and we'll use it as account1.findBalance followed by parentheses. Withdraw. It will be a method attribute and we'll use it as account1.withdraw and inside parentheses we'll pass in the amount to withdraw as input argument. Likewise, there will be a method attribute deposit to deposit amount into the account. As another example, let's consider a point as the class for points on xy plane and consider p1 as its one object. This class can have following attributes. X. It will be the x coordinate of the point and will be a data attribute and we'll access it for p1 as p1.x. Likewise, it will have a data attribute y for the y coordinate of the point. Now consider an attribute mag for the magnitude of the point, which is the distance of the point from origin. Think for a moment that it should be a data attribute or a method attribute. Basically, it can be set as data attribute or it could be a method attribute returning the magnitude of the point. We'll discuss in detail whether to make it as data attribute or method attribute later in the course. Now consider this attribute move x direction that should move the point in x direction. This should be a method attribute and we'll use it as p1.moveXDirection and pass in the unit amount we want to move along x-axis, for example 2 as input argument. Likewise, move y direction will be the method attribute. Move radially should also be a method attribute to move the point radially. As last example, consider triangle class and try one as one of its objects. It can have data attributes like side 1, side 2, side 3 or the type of the triangle. The attributes area and perimeter can be data attributes or the method attributes. Again, we'll discuss later what to prefer for these attributes. Then it can have method attributes like rotate to rotate the triangle and translate to translate it. Now let's have a little comparison between procedural programming and object-oriented programming. Firstly, procedural programming is a top-to-down design approach while object-oriented programming is object-focused design. Secondly, in procedural programming, there is limited code reusability. We can have reusability through user-defined functions, but in object-oriented programming, code reusability is very strong. Thirdly, in procedural programming, it is a complex code While in object-oriented programming, we have a complex design in the form of a class, but once we have done that, the use of the class is quite simple. Now I'll mention about 2 points you should consider before starting to code object-oriented programming. Programming in general is all about thinking pattern, and for object-oriented programming, you must consider 2 things. First, that the class you are creating is meant to be used by some programmer rather than the end user. As past practice of coding in procedural style of programming, we consider that the user of our program will be the end user who might not have any idea of programming. But in object-oriented programming, we create a class for ourselves and for other programmer who will be using our class in his program. Secondly, there can be many programmers who will be using the class you are creating, so you must try to provide as many features as you can. Just to make the points a bit clear, consider that you are creating a class named as polygon for polygon on xy plane. And this class has 3 data attributes and 3 method attributes. The program using this class may need these many statements for some processing on polygons. Now if we add a few more methods, like total 9 methods in class polygon, then the program using this class would need lesser statements for the same processing as in first case. And if we add a few more methods in our class, the program using this class might need even lesser statements. And it's not just one program using our class. There can be many programs and many programmers using our class. So designing a class with more and more features will be beneficial later on. That's all from this introductory lesson about object-oriented programming, and from next lesson we'll start coding the classes. Thanks for watching and see you in the next lesson.